the MCAT podcast, session number 152. A collaboration between the medical school headquarters and Next Step Test Prep, the MCAT podcast is here to make sure you have the information you need to succeed on your MCAT test day. We all know that the MCAT is one of the biggest hurdles you'll face as a pre-med, and we're here to give you the motivation and information that you need to know to help get you the score you deserve so you can one day call yourself a physician. Welcome to the MCAT podcast. My name, as always, hasn't changed. It's Dr. Ryan Gray. Thank you for taking some time to join us today. If you are new to this podcast, thank you. You have a lot of episodes to go catch up on. I get messages all the time from students who listen to this podcast, who take a few practice tests, and they score phenomenally well. And they think it's the podcast that's doing it. Well, number one, it's them, right? They're taking the test. But number two, this is a phenomenal resource, free resource for you to get MCAT advice. So subscribe, go listen to all of the past episodes, let your friends know we are here. Today, Claire and I are jumping into another high-yield topic all about molecular genetics. Claire back for some more MCAT podcast. I love these high-yield topics. I think students are going to love them. Amino acids, like we covered last week, and molecular genetics this week. Now, I read that when you sent it to me, and I'm like, what the heck does molecular genetics mean? So let's first start with the definition of molecular genetics.
Right. That's the first part. You have to just know what the topic is. So basically molecular genetics is, it's a huge topic. It covers things like DNA, RNA, protein structure. And basically the reason why we have that word molecular in there is to distinguish it from classical genetics. So classical genetics is like Punnett squares, the pea plants are yellow and then their offspring are green. And classical genetics is something that I think MCAT students always study like a lot because they're super used to it from college. But molecular genetics actually tends to come up even more often. So we're going to see a lot of DNA mutations, that sort of thing.
Okay. All right. So let's go ahead and dive into our first question. Again, if you want to follow along at the MCATpodcast.com/152 for episode 152. I'll go ahead and start here with question 20. A missense mutation replaces an alanine residue located in the interior of a soluble plasma protein with a valine residue. Due to this change, the protein will most likely A, suffer a complete loss of function, B, be largely unaffected, C, display disrupted folding due to the mistaken inclusion of a polar amino acid, or D, display disrupted folding due to the mistaken inclusion of an unusually bulky amino acid. All right, so I read this and I'm like, great, amino acids again. So obviously we're going to have to know some of the amino acid properties here to be able to think about C and D. But then we also have to understand kind of DNA and RNA and transcription and all that stuff and translation, all those words that I forget what they mean, and try to think about if something replaces another thing, how is that going to affect things? So I'll let you go ahead and work through these with me.
Totally. Yeah, that's the thing about molecular genetics. It just touches on all of these processes. And for this question in particular, we can see right away it deals with mutations. So I would probably start by just figuring out what they mean by missense mutation. Like, what is a missense mutation? And what you should know for the MCAT is that a missense mutation is just a mutation where one amino acid in a protein is replaced by another amino acid. So there are all sorts of other kinds of mutations, nonsense mutations where an amino acid is replaced by a stop codon and that sort of thing. But here we just replace one amino acid with another. And in particular, they told us we replace an alanine residue with a valine residue. So now we actually can see that even though this is a genetics question because it's about mutations, it also touches on amino acids like everything tends to do. And so we just need to figure out what the difference is between alanine and valine. And alanine and valine are actually the exact same kind of amino acid. They're both non-polar amino acids. And that makes this what we call a conservative missense mutation, which means that one amino acid is replaced by like a really similar amino acid. And when that happens, it tends to largely unaffect the function of the protein. So that gives us B, which literally says be largely unaffected, and that's the perfect answer.
And how do we know that they're similar in replacing so that we would know that it would be unaffected?
Yeah, so to know that, you have to know the characteristics of their side chains. So I know we've talked about this in the past, but side chains can be nonpolar, they can be acidic, they can be basic, etc. And here, if we had this memorized about both of these, we had like alanine, okay, that's nonpolar, valine, that's also nonpolar. That's all you need to know. If they're the same type of side chain, then you can assume that if one is replaced by the other, it's not going to make much of a difference.
I can see a drinking game starting to come out of these podcasts where every time Clara mentions side chain, everybody takes a drink of Diet Coke.
Right. We're taking a lot of drinks.
Yes. Non-alcoholic beverages only. Please drink responsibly. Okay, so again, just kind of understanding, again, even though we're in molecular genetics, amino acids can come back to haunt you. So understand all of that stuff and side chain. There you go. Hope you don't have that drinking game going. All right, question 35.
All right, I'll read this one. 35. A drug that disrupts hydrogen bonding would most directly affect what level of protein structure? A, primary, B, secondary, C, tertiary, or D, quaternary?
A drug that disrupts hydrogen bonding. And so we'd have to know the structure and where, like what is each structure relying on for that structure, and where hydrogen bonding comes into play. So it's interesting for me. If I were to kind of think through this again, I'll try to actually answer this one without handing it off to you. But to me, hydrogen bonding is like the most basic kind of bonding. And so I'm like, oh, yeah, like quaternary, like that's super advanced. Like hydrogen bonding's got to be way more basic than that. And tertiary and secondary and primary. So I'd probably go with secondary just because I'm like, maybe not primary. Let's go up one level and go to secondary. But that's just my thought process there.
You're right.
See, I'm good. There you go. Pick B and move on. So actually, why don't you give some real meaning behind how I got to that?
Totally. Yeah. And I think if you sort of take your thought process and at its core, it's not wrong. Because basically, so hydrogen bonding is really fundamental. It holds together a lot of the structures that we see every day in biochemistry. The thing, though, is that the most fundamental type of bonding, the bonding that literally holds together the individual subunits of a protein, is actually covalent bonding. So specifically peptide bonds. So proteins, peptide bonds, primary structures, that's choice A, is held together by peptide bonds. So A is out, and then we just have B, C, and D. And tertiary and quaternary structure are sort of like you said, like these really higher level forms of structure. And they totally are impacted by hydrogen bonds, but they're also held together by other forces as well. So like tertiary structure is held together in part by disulfide bonds. And then quaternary structure is very similar to tertiary structure, except it is interactions between different subunits instead of within the same subunit. So tertiary and quaternary, I like to think of as being held together by like all these different factors, whereas secondary structure, the only thing that holds secondary structure together is hydrogen bonding between the actual backbones of the amino acids. So a drug that disrupts hydrogen bonding would totally ruin secondary structure, and then B is perfect.
All right. I got one right. Woohoo!
Woohoo!
There we go. All right. We got sound effects, people.
Nice.
All right. Question 44. A student stains a cell and views it under a light microscope. He correctly identifies the nucleus and notices dark and light regions within its structure. He then tells his lab partner that the dark areas represent euchromatin and are associated with decreased levels of transcription. What is incorrect about this student's assessment? A, euchromatin, which he has identified, is actually associated with increased transcriptional activity. B, he has actually identified heterochromatin, which is associated with increased levels of transcription. C, he has actually identified heterochromatin, but is otherwise correct. Or D, nothing, the student is absolutely right. Oh man, staining and cells. I remember those good old days. So dark and light regions in the cell. And he is trying to say it's euchromatin, which is decreased levels of transcription. And so this one is like you just have to know how staining works. What is staining going to stain more than something else? I think, if I remember correctly, that euchromatin actually doesn't take up the staining, and so it wouldn't be dark. I don't know if that is correct or not. Is that correct? Let's start with that one.
It is correct.
Okay, so there was just something about that. I was like, that just doesn't sound right. And so euchromatin does not take up the staining, so that would be wrong. And so question A is out, and question D, or answer choice A and answer choice D, are out. So we're left with B and C, which I'll always take at least a 50% chance, better than 25%. And so he has actually identified heterochromatin, but now the question is, okay, heterochromatin, is that where the increased levels of transcription are? And I would go with B, just because I'm going to take my 50% and move on.
You were almost there. It's C.
All right.
Yeah, but no, you were totally right though about the heterochromatin part. So the question stem says the dark areas represent euchromatin, but euchromatin is actually the really loose version of chromatin. It's like really loose and like not condensed at all. So it looks really light under a microscope. So this must be heterochromatin, which looks really dense, really dark under a microscope. So that gets us to our B and C. And then the only place you went wrong was picking B. And instead, our answer is C, basically because since heterochromatin is a really dense version, like the dark part, it means that it's really hard for enzymes to get into the little grooves of that structure. So things like RNA polymerase, which is going to transcribe our RNA, or our DNA, RNA polymerase has a lot of trouble getting into heterochromatin. So heterochromatin is absolutely associated with decreased levels of transcription. So the student's totally right, except he messed up euchromatin versus heterochromatin, and C is our perfect answer.
Okay. So that's just an easy kind of, let's think about logic. If it's tightly packed, there's just no room for any of that activity to go on.
Yes, exactly.
Okay. All right. Another good podcast. Anything else about molecular genetics that maybe we should end with here?
No, I think I just want to emphasize how important it is to completely study it very, very thoroughly. Right. So you might see like multiple chapters in your biology book that all relate to molecular genetics, like one about like nucleotides, one about, mutations or something like that. It's all important. We saw here that there's a pretty wide variety of stuff that can be asked about it. So make sure you have it down.
All right. So there you have it. Molecular. It's hard for me to say. Molecular genetics and high yield topics. I hope this was helpful for you. Help guide you a little bit more on your path to a tremendous MCAT score. If you are looking for some more one-on-one help with the MCAT, Next Step Test Prep started as a tutoring company. And that is what they are really well known for, is really high quality MCAT tutors. So if you need a little bit more one-on-one help with a tutor, give Next Step Test Prep a call. You can call their 800 number. They have free 15-minute consultations. Call 888-530-6398 to speak to one of their MCAT consultants today. Again, that's 888-530-6398, or go to nextsteptestprep.com and fill out the consultation form right there. Hope you have a great week. We'll see you next time here on the MCAT podcast.
This is MedEd Media.